All right, today we're going to do a little ghost hunting, but not in a haunted house. We're going deep inside your app's memory. We're going to tackle a really important and, honestly, an often overlooked question in Swift security. What really happens to something like a password after you're done using it? The answer might surprise you.
I mean, really think about it for a second. Your user types in their password, your app validates it, and then what? You'd think that password just vanishes, right? It's so easy to just assume that Swift, being this modern, safe language, just cleans it up for you, takes out the trash. But is that what's actually happening?
And boom, there it is. The hard truth. Swift does not automatically go back and wipe that memory clean. That means the password, that really sensitive piece of data, is just left there. It's lingering, kind of like a ghost in the machine. So this ghost in memory, it's not just some spooky metaphor. Nope, it's a real, genuine security risk. Let's break down exactly why this is so dangerous.
And look, we're not just talking about passwords. This ghost can be any secret your app handles. Think about it. API tokens, private encryption keys, maybe even sensitive financial info. Basically, anything an attacker would absolutely love to get their hands on could potentially be just sitting there in plain sight.
So how would an attacker actually find these ghosts?
Well, if they can get access to a device, especially one that's jailbroken, they've got a few options. They could attach debugging tools right to your running app, or, and this is the really scary one, they can take what's called a memory dump, a full snapshot of your app's memory, and just sift through it later, looking for all those juicy secrets you left behind.
And that brings us to the most important point of all. Since the system isn't going to do this for us, it's on us. It is our job as developers. You could say, we have to be the Ghostbusters. We have to take deliberate, active steps to kick these data ghosts out of memory for good.
Okay, so how do we actually bust these ghosts?
Well, our first tool in the toolkit is the most direct one. We're going to take manual control of the memory where those secrets are living, and we're going to wipe the slate clean ourselves. So here's the basic game plan. The absolute key here is step 1. Stop thinking of your secrets as a string. Instead, convert it into a mutable data object. Why? Because that gives you direct access to the raw bytes underneath. Then, once you're done with it in step 2, you can move on to the most satisfying part, step 3. You just overwrite that whole memory buffer with zeros. Poof, the secret is gone.
Now, sometimes you need to get even closer to the metal. For those moments when you need absolute, total control, like say you're working with a low-level crypto API, you can go even deeper with unsafe mutable bytes. This thing gives you a raw, direct pointer to the memory. It lets you get in there and manually overwrite everything, byte by byte, making absolutely sure that not a single trace is left behind.
But just wiping memory after the fact is a bit reactive. A much smarter, more proactive approach is to design our code so the ghost barely has any time to exist at all. And that brings us to our next strategy, smarter data scoping.
I love this slide because it shows the difference so clearly. On the left, you've got the bad habits, storing secrets in global variables or in these long-lived objects like singletons. That's like letting the ghost have the run of the entire house, haunting your whole app. But on the right, that's the best practice. You keep the sensitive data in the tiniest scope possible. You use it, and then you clear it out immediately. The less time it's around, the smaller the window of opportunity for an attacker.
Okay, but what about data that you need to keep around, like between app launches? For that, we turn to our most powerful tool. We're going to stop trying to manage it ourselves, and instead, we're going to lean on the OS's own built-in secure vault, the Keychain. And this is a really crucial mindset shift. For any data that needs to stick around, like user credentials, the best practice is to not keep it in your app's memory at all. Seriously, you should be using the Keychain. It is a secure database managed by the operating system built specifically for this exact purpose. So what makes the Keychain so great? I mean, where do I start? First, it encrypts everything for you automatically. On modern devices, that data is protected by the Secure Enclave, which is a dedicated security chip right on the processor. But most importantly, it minimizes that memory exposure we've been talking about. You only pull the secret out right when you need it, use it, and then you let it go. When you put all this together, the manual clearing, the smart scoping, using the Keychain, you realize they're all just parts of a much bigger idea. And that idea is what we call the security mindset.
Yeah, a real secure coding mindset is about understanding that security isn't just one thing you do. It's not just one function call. It's about thinking about the entire life of a piece of sensitive data, from the moment it comes into your app to how it's used and all the way to the moment you securely destroy it. So let's just recap the pillars of this mindset. 1. Be active. Don't wait around. You have to manually clear that sensitive data. 2. Be disciplined. Keep the scope, the lifetime of your secrets as short as humanly possible. And 3, be smart. Use the powerful OS-level tools that are already there for you, like the keychain, whenever you can. And that leaves us with one final and really important question. After all of this, I want you to really think about your own projects. Think about the code you've written. Are you leaving ghosts in the machine?